Hello, this is Paul from Foresight Tech. In this lecture, we are going to evaluate this type of integral, which is the nth root. This is irrational, right? So the method is we call the rationalizing substitution, which means what? By substitution, and the integral goes to rational, means a rational function. And then after we get a rational function, we know, right, how to find. If we summarize here, it's this. At the beginning is irrational. By substitution, keep in mind the substitute of the whole term. And then we will go to integral of a rational function. And then how to do? Use a partial fraction method, right? Then we can get what we need. I'll show you one example here. So look at this, the integral. So how to do substitution? Everyone, you remember, we know. So this n equals 2, right? This n equals 2, okay? So this substitution, after the substitution here is this. Okay, the name, everyone remember, the name is rationalizing substitution, right? Okay, up here. What did the substitute? So u equals, so we have to u equals the whole term, which is square root of x plus 4. Okay, this is the one we need. And then we're going to do substitute. So that's u. What is x? We need to find what is the x we need to find. From here, we definitely can find all. Square both sides. So you can get x equals u square minus 4. And then take a derivative. We can find that dx equals what? 2u du. See, we know everything. Now we can do substitution. Okay, so what is my substitution? We put it here. So I say this I put here. Okay, it's equals what? This is integral. Okay, now after substitute, so the top goes to u, the bottom goes to u square minus 4. U square minus 4, and what is dx goes to 2u du. Okay, so now look, it's much easier. Is this a rational? Definitely, right? We don't have a square root or something. But we can simplify a little bit. I can simplify to put it here. 2 we factor out, and then the integral goes to this. U goes to u square, and the bottom is the u square minus 4 and the du. Okay, so now we look at this. We look at so we put it here. So can we see? This is what is a rational already, right? Good. This is already a rational function, but be careful. We cannot directly use the partial fraction because what? This is not proper. This is not proper, or it's called improper. Right? This is improper. So what we need to deal with the improper? Long division. Remember that? We learned the long division from 171. Okay, so here I show you how we're going to do all the detail. If someone remember, so this is the one we need. The long division is this. Okay, first we put, and which one? U square. So u square we put here, divided by what? By u square minus 4. So u square minus 4 we put here, and then this divided by that. The first term divided is we get 1, right? Okay, so 1 times this, we get a u square minus 4, and then we do subtraction. What do we get? We get 4. Okay, and from this we can, 1 is the quotient, and 4 is the remainder. Remember this? Okay, and if we have this, we definitely can break it down. Break down this improper to proper. What is the proper now? So parenthesis, quotient is 1 plus proper fraction. What is the bottom? The original divisor. What is the remainder? 4. If for someone you remember that, okay, so here is what we need. So now definitely we can see what we can see. Okay, this, the second term definitely is proper, right? It's proper. If it's proper, we can directly go to partial fraction. We can find the partial fractions, and then we can find the answer, right? What is the partial fraction if I copy here? Okay, partial fraction 4 over u square minus 4. already get the answer. Okay, so I put here first. -1 over u plus 2 plus 1 over u minus 2. Okay, and this result, the detail I will show you next page. Okay, I will show you how to do this the next page. If we already did the decomposition, now what we need to do is just plug in, right? Okay, so I put here is 2 integral 1. See, this is the first is plus negative is minus, so I just do this minus 1 out of u plus 2 plus this term plus 1 over u minus 2 du. Okay, so now easy. This one has derivative of u, this have ln, this have ln, alright, remember that? Okay, so I directly find the antiderivative for each term. So it's 2. So now the first is u minus, okay, is ln absolute value u plus 2. Keep in mind that this is a composite. However you use the chain rule, you will definitely get that. This is the same, okay? So plus ln absolute value u, sorry. Okay, so here's minus 2, so minus 2. And then plus c. Okay, before we're going to do back substitute, so we can do a little simplification, okay? If we put these two terms together, a minus b is a over b, right? The quotient rule of log. Or we can use that to simplify at least a little bit. So after we simplify, what do we get? Now we get a 2u plus ln, the quotient. What is the quotient? Okay, the quotient is this. This one u minus 2 over this u plus 2 and plus c. Now the last, you know what do we need to back, right? We need to back substitute. After back substitute, here is the final answer. U is there, right? Is square root x plus 4. Good. And ln, this is a complicated term. Okay, so I put here fraction. What is u? Square root of x plus 4, then minus 2. This is du x plus 4 square root of n plus 2. Parenthesis and then plus c. That's the answer. Probably someone remember rationalize denominator. Okay, if you like, you can go. Okay, or you just leave it here. I said that I was going to show you what the detail for the partial fraction, right? So this one, and the detail is here. I'll just go over a little. So because the factor is linear, so linear factor, remember we have the basic decomposition, right? So the first a and the b, and then multiply by the LCD, we get the basic equation. AB, how to solve AB? So these I use the method to plug into special value. I plug u equals -2 to get A, and then I plug u equals 2 to get a B. See, AB we get it, and then plug into 1, we get what we need. So that's exactly the previous questions that we should. That's all. Thank you.